So here's a few really fascinating things. So number one, we're going into deep learning and non-supervised feature extraction, right? Then you deploy it as a web service, where historically data scientists, if I talk to kind of the normal data scientists, maybe not your advanced researchers, but in the day-to-day businesses we see, right? So they say, oh yeah, 80% of my time I spend cleaning the data and creating my feature vectors, this and that, and 20% of the time, I'm just messing around and trying to find the right algorithm here. It almost sounds like that, deep learning and those capabilities, deploying this as a web service, will make them jobless.
I wouldn't say jobless. I think it'll make them a lot more efficient. Right?
But there's this rush to be a data scientist, right? Where I think the technology is catching up. It's like trying to be a cab driver right now, and we all know in 5 years we have self-driving cars.
Yeah.
No?
So actually, I have a slightly different way of looking at it, right? Because I think if you take any industry for that matter, data scientists, for good or bad, I think the lot of romance and the lot of excitement about this is people say, hey, you can learn things automatically. Mm-hmm. There are things like deep learning that do computer vision, that can do applications like this, etc. But when you get around to actually working on a real data problem, mm-hmm. as you said, a lot of the data goes in, hey, how do I get the data? There's this much data. How do I pull it? How do I join it with 10 other data sources? How do I clean it? How do I transform it? How do I figure out where does my data live? Who do I need to ask for access?
Right.
And when I find about this, are these values reasonable for this problem? There's a lot of that question and that investigation that happens. And it's only the last 10% of that exercise that you're really training models and saying, hey, I can predict this 2x better than what somebody else can do, etc. But to me, that gives you a good understanding of the data, and I think it's a very important part of the process. That sort of data wrangling and data munging and sort of immersing yourself in that data is very important as well. But also, a lot of those things I feel can be automated, right? Especially a lot of the common patterns, a lot of the common processes and insights that people get from this data can possibly be automated using tools, right? And I think as a community, we need to do a much better job in that. Once we take that out, then you can really move the innovations upstream to say, okay, how do I really get better at building intelligent applications? I mean, I personally think about data science. By the way, I also really, thinking back at it, data science seems to be a very interesting term on this, because if you look at it, I think statisticians have been working with data for hundreds of years, right? So perhaps now, as you mentioned earlier, with computing and with the availability of data, you now get an opportunity to work with large amounts of data and do much more heavy-duty computing. But really, many of the techniques that's been around, the fundamental techniques have been around for a while. Yes, there is a lot of innovation happening, absolutely.
Yeah.
But also, there's been a lot of fundamental techniques that have been around for a long time.
Right.
And so the place where I personally feel data science is really building intelligent data-driven applications, right? It is less, I think, to do with building a model that has a good ROC that I can show in a slide or in an Excel spreadsheet. But really, how can you stand something like an application like this that is intelligent, right? It is deployed, it's running in production, it's actually delivering value, right? And you can take some actions with the models. That's where I think the real value is. I mean, my VP Joseph Sirosh has this very nice quote about data and the utility of data. He says data by itself is useless, right? Really, he says it's like $0.
Yeah.
And he says insights and predictions are probably worth pennies. But actions, intelligent actions that you can do with data, right? Intelligent automated actions that you can do with data are really worth dollars.
Yeah.
Right. And I think that's probably where we need to move the whole conversation around to say, okay, how do we, as the community working in data systems, and I interpret data science broadly as everything to do with collection of data, ingestion, streaming, all the data engineering, plumbing things that we do, the systems. plus the algorithms, plus the models, plus the deployed solutions, right? Operationalized, deployed solutions in production that are delivering value. To me, that's what I call as a full stack data scientist. In fact, the full stack data scientist to me is even somebody who has the business sense, who can work with product managers. But I think we need to, as an organization, I mean, as a community, I think if we define that as our full stack data scientist, I'm sure there will be a lot of people that would, and design trainings and design workshops and course materials and tools to make that whole thing easier. I think that's where the community can really aspire to be.
Yeah, I found sometimes that, you know, those subject matter experts that then get into, you know, data science are the most successful because they bringing the understanding of the subject, right, and then apply creativity, right, and not just, you know, vanilla kind of algorithms and see, you know, what happens, but really kind of the art really before unsupervised learning is to, you know, come up with the right feature vector, right?